Okay, I think we can get started. Hi, everyone. Thanks for joining us for the 5th Ballerina community call. Today, we'll be talking about code to cloud. But before we get started with the session, I just wanted to kind of tell everyone how you can get involved in the community and how you can engage with the Ballerina team and wider community as well, just before we get started. So if you go through the community repo in the Ballerina platform GitHub page, you can see all the information regarding our community. So first, let's take a look at how you can actually engage with our community. So we have a Slack channel that you can join. We have over 1,000 users, and our development team is actually very active on this channel. So if you have any questions regarding this, regarding Ballerina or anything you're working on Ballerina with, you can ask your questions here. And also we'll be giving updates on releases and anything like the community call and events that are happening as well on this channel. You can also join the discussion on the Ballerina developer group. That's another way that you can kind of talk to either the wider community or the development team. And if you have any questions on Ballerina, you can also go to Stack Overflow and use the Ballerina tag. We'll get back to you there as well. So some of the channels we use to kind of give updates on content and events and things like that, and releases as well. It's our Twitter channel. So you can follow us on at Ballerinalang. So we give updates on things like any kind of content that we publish, if we make a major release, and if we have any events that we're speaking at coming up. And we also have a Ballerina newsletter that where we curate like a whole bunch of content around a specific topic. So we've already given out, sent out 5 newsletters, and we've talked about topics like gRPC, microservices, serverless, and things like that. So it's a periodic newsletter. So if you do want to keep up to date on Ballerina and the content that we push out, this is something that you should subscribe to. So going back to this community repo, of course, we have the community call. You guys have joined this today. Thank you again for joining. I'll talk a bit about the format and things and some of the links that would be helpful to you in a bit when I go to the slides. I also wanted to tell you how you can actually contribute to the community. So you can write content for us. You can record videos and publish them either on your personal blogs or on external publications. You can also speak at external events about Ballerina, like meetups and conferences, or even host your own event. And if you do this, we will support you in any way we can, including things like training resources and logistics, any kind of logistics that you need help with, and if you need any swag and things like that. So you can contact us at contact@ballerina.io, and we are happy to help with any of these resources. You can also contribute to the language. So you can do that by reporting an issue, by publishing a module on Ballerina Central, or you can even contribute to the source code and start our Ballerinalang GitHub repo. So in this community repo, we also have a form here. So if you have contributed in any way to the community, you can send in any of your work or any kind of request through this form, and we will be happy to help you out, maybe by promoting it or sending you something, some kind of swag or something like that. Yeah, so let's go back to the slides. I'll tell you a bit about the community call before we get started on the session. I hope you guys can see this. Okay, so this is a monthly meeting, and we try to have it, this year we're trying to have it on the last Tuesday of every month, but this might change depending on holidays and things like that. But the plan is to have it every last Tuesday of the month. And the community call structure is, so one of our technical, somebody from the development team will explain a feature in Ballerina and take you through a live demo. And during the session, you can actually send in your questions via the YouTube chat or the Zoom chat. But after the session is over, we do encourage you to kind of get involved in the conversation and have an open discussion with the speaker and other attendees. So if you are on the Zoom call, do unmute yourself and ask questions after the session is over. The recording and slides will be published on the YouTube channel as well. And the report that I showed you before will have all of that information uploaded in the community calls folder as well. So some useful links. So I'll be sending this a link to the slide deck to both the chats in a bit, so you guys can kind of access all the links that we've mentioned here as well. So the agenda link, it's basically like a working doc where we have all the information of past calls and links to the recordings and things like that. And if you want to be notified of the call in advance, like we'll send you a notification in advance via your email if you fill in this form. And also if you do want to get involved in the call, so you can even present something that maybe you have worked on with Ballerina, or if you want to suggest something that we should be talking about, you can fill in this form. And one more thing before we kind of get started, I just wanted to mention that we are releasing the alpha, Ballerina Swan Lake alpha this week. And so if you're a new user, you can download it at this URL, ballerina.io/downloads. So it's actually after the stable release. So if you scroll down, you'll see the alpha release details. And if you're an existing user, you can update the distribution using the update tool. And those instructions will be there in the downloads page as well. So all the new features and all the improvements that are shipped with this release will be available on the release note, which is also linked to from the downloads page. Yeah, that is it from me. I'll be handing it over to Anuruddha, who will be talking about Code to Cloud with Ballerina. Thank you so much, Anuruddha, for joining us today. Over to you.
Thanks, Sam. Share my screen.
Yeah.
Okay. As for today's, we'll be discussing about Code to Cloud functionality of Ballerina, specifically for Kubernetes. So we'll be deploying a Hello World service into Ballerina Kubernetes. Then we will scale the code in the Kubernetes, and then finally we will run the Cronjob in the cloud. So first of all, let's see what Code to Cloud means. So if you have developed a program that needs to be run on cloud, specifically Kubernetes, you know the drill. So what you do is you write the code, then you pack the code into a Docker image, then you write the toml files, and then finally you will deploy it and see in the production. So in Ballerina, we wanted to change this approach. So what we wanted to do is we wanted to create all these artifacts at the compile time and compiler. So it will be less error prone and more developer friendly. So let's move on to the next one. So previously we had if you are familiar with Ballerina 1 releases, so we had a model where we have to annotate a service or a function or a listener to generate the Kubernetes artifacts. So going forward, we tried to we found some difficulties in this approach. So one will be that developers need that in-depth knowledge of Kubernetes. So he knows to know about what ingress is, what HPA is, what pod autoscale is, and etc. to use these annotations. So what we did was, and it is also not scalable. So because when we cannot support all the things that are in the Kubernetes in these annotations. So we found that it is not scalable. So in the new approach, what we did was we decided to generate only the bare minimum that user need to deploy and test his or her application in Kubernetes. So In the new approach, there are no annotations. You just have to write the code and you will have to build the file with this special build option. So -- cloud equals Kubernetes. So when you use this command, it will generate the Kubernetes artifacts, the YAML file and the Docker image and the jar file. The Docker image will contain all the generated jar files which are ready to run in production. So if you in this approach, how we can change the default behavior of the generated artifact is we have introduced a new file called kubernetes.com. In this one, you can provide the supported configurations that are required to run your program in Kubernetes. So the value, if something is specified in this Kubernetes toml, we will use this value. Otherwise, it will be generated using the default values that we have programmed. So let's move on to our first example. We will be developing a Hello World service in Kubernetes. So let me show you my code. So this is the sample one that I'm going to deploy. So I'm using Ballerina Alpha 1 release along with Docker for Desktop Kubernetes cluster. And in this service, we have a simple Hello World service which runs on port 9090, and it has a single resource function which says say hello, which when invoked, it will return this hello world from Ballerina message to the user. So and this is the Ballerina package. So we only have one file, and in the kubernetes.toml file, we have container image related configuration. So what it says is this image should be having a repository called Untitled, and its name will be Hello API, and the tag should be sample1. So let's build this one. So I'm going to use Ballerina build -- cloud equal Kubernetes options, build this. So in this one, it will first generate the Kubernetes service deployment HPA and the Docker image. So let's see what it has until it generates the Docker image. Let's see what's generated in the Kubernetes file. So it will be created in the Kubernetes target Kubernetes folder. Here we have generated a service which exposed port 9090, and we have created a deployment which name hello deployment, which is the default value that we have taken from the ballerina.toml descriptor. And here the generated Docker image, we have the tag. If you remember that Kubernetes toml had this tag information, so those values will be entered into this image spec, and container port is included. And finally, we have a horizontal pod autoscaler which has a default value, default CPU utilization and resource limits. So now the image, Docker image and artifacts are generated. You can see the command that needs to deploy this one in the Kubernetes. First, let's say check whether the Docker image is built. I'm going to run Docker images command. So we have this unroot hello API sample1 built now. So let's deploy this one using this command. So it will generate the service deployment and a horizontal pod spoiler. Let's see whether it's deployed and running. The pod is up and running, and we can do a get svc, and the service is created, and the HPA is also created. So in order to access this one, if you look at the service, this is exposed as a cluster IP. So we need to export this as a node port to access this service. So what we are doing is we can run this command to expose this as a node. So once it is created, a node port service will be created. Now you can see get svc again. And you will see that svc local is created with node port, and it's the port 9090 is exposed via 30,135. Now we can access this one with this command. Port should be 3175. And we can see that the message is received successfully. So let's remove, undeploy this one. And the service that we just created. Access this. So if you remember, we didn't write a single YAML or a single Docker file or Docker image command to deploy and access this service. So everything will be generated by the compiler, and we just have to deploy and access this one.
Anuruddha, good morning. I've got a question. Is it a good time to ask?
Yeah.
So in this sample, I noticed, so we have a Ballerina service, and I saw that you have also created a Kubernetes.toml. Is that a must, or can I skip?
Yeah. Yes, sorry. I forgot to mention this Kubernetes toml file is not required. So it is just created there to change the Docker image. If I remove this Kubernetes.toml file, and I can simply build this one with Cloud Kubernetes option, and it will generate the same thing with the default values.
Okay, so I just need to write my code, and then when I build with the Cloud Kubernetes option, it will build the necessary descriptors. Okay, thank you.
Thank you for the question. So if you look at the YAML, now you will see that image name is changed. It will be hello colon latest without the repository because we didn't write those values. Okay, now moving on to the second sample. Here we have in this one we'll be showing how we can scale a code in Kubernetes. So we have written a simple CPU intensive program in Ballerina. Here also it is a service. We have a mat service which has get square root function. What it does is it will call this sum square root function which calculate the square root sum of the square root for 1 million numbers. So it will take some time to calculate, and meanwhile we are going to scale this one using the Kubernetes toml descriptor. So what we want to do is we have in the Kubernetes toml we have specified the repository name and image things, and we have specified the minimum memory and maximum memory to be allocated. And minimum CPU and maximum CPU also provided. So we have given the auto scaling configurations here. So we have said it should have minimum of 2 replicas and maximum of 5 replicas. And when the CPU is greater than 50, we should scale this one. So let's build this one and see what output looks like. So in this one, I'm just going to use Ballerina build because we can provide the build option in this toml file as well. If it is provided in the toml file, we don't have to use this -- cloud option. It will automatically generate each time you build. So here also we have generated service deployment and a horizontal port autoscaler. So if you look at the scaling sample, we have the port 9090 and Docker tag, and memory request and limits are set correctly as specified in the Kubernetes.toml. And the minimum and maximum replicas are also set in this HPA. So while it generates, okay, the Docker image should be generated now. Let's see that. So this on there math v1 is generated. Now let's deploy this service. Let's see if the pod is running. Pod is running and the services is up. And then HPA is running. So we will let's create a watch for this HPA. So it takes some time to publish the first resource. Until then, the target piece will be unknown. So while if you look at this one, the replica count also increase. Now, if you remember, we asked for minimum 2 replicas, but initially there were only one when we run this kubectl pod command. Now let's see whether there are 2 replicas. Now there are 2 replicas running and it should be publishing this matrices soon. Once until the matrix file, we have this command which invoke this API rapidly and increase the CPU usage of this pod. So let me run that one. Let's wait for this first matrix to be published. Okay, now you can see only the 1% of CPU is used. Now we are going to run this command, which will be invoking that service repeatedly. Now we see that it's invoking rapidly, and we should be seeing this one scaling under a minute. We have reduced the thresholds as well. Should be 50% and 100. It's around 1 minute. Okay, now we can see that CPU rate has increased, and now it will be replicated onto 5 pods. Currently there are 2 pods, and now it's scaled to 4 pods. Now if you do a kubectl get pods, there are 4 pods running. So you see that these connection refuse messages are coming because we are invoking before the service is ready. So what you can do is add a readiness probe and liveness probe to this service. I'm not going to demonstrate the usage, but let me show you how you can add it. In the toml, you can just say kubectl probeness liveness, and here you can give the path as, let's say, port first. We want to run this one on 9090 port, and the path as live or something. So we can just give this one, and we can add this part to the service as a resource, and we can check whether the service is ready and live before invoking this one. So this is the sample 2, which runs on one. So if you see now, the pod should be slowly scaled down. It's also good. Now I'm going to delete these services. it will be removed. And as for the third one, example, what we are showing is a Cronjob. So in this one, we have used the annotation-based approach to define the Cronjobs, because you normally apply this one on functions, and it makes sense to add these schedules in the annotation rather than in a separate file. So in this one, what we have is a simple hello main function which runs on every single minute and exit. So to compile this one, we just simply can run build cloud equal Kubernetes. Since this is a single file, I have to give the that file as well. So here it generates the Docker cron job and the Docker file. If you look at the generated artifacts, you can see that the cron job is generated and the schedule is repeated. And special thing about the Docker images that we are generating is we are generating a layered Docker file, which will be which is very effective in storage and pushing and pulling. So each layer can be reused in other Ballerina Docker images as well. So once you push this Docker image, if it has the same dependency, it will be automatically mounted from the Docker instead of republishing. So the Docker is created. Now let's deploy this command. So the cron job is created. Now we can see put ctl get cron job. Now this cron job is created. Now we can see each minute the other pod gets created and print the message. Let's give it a watch. So once a minute passes, it will be created and export. Okay, so the container is created and the job is completed. Now if we look at the logs of this file, we see that the hello world is printed. So this is the demos that I have prepared for this community call. Apart from that, we support generating config maps and secrets as well. You can use the links to see how we can do that one. And here also we have some suggestions, the tooling support for this Kubernetes terminal, so you can understand what kind of things we can change in each Kubernetes terminal section.
Anirudh, sorry, I have another question.
Yeah.
Can you please go back to the sample service code?
Okay. This one?
Yeah, the VS Code. The line number 4, the HTTP :service, is it a must, the service type?
No,
No, the other side, the HTTP :service.
At the moment, we are supporting HTTP. We can create a gRPC service as well.
No, sorry. My question was like, so you should, with the service keyword, we have the service type HTTP :service.
Yeah.
It's usually optional.
Yeah, we can.
We can remove it. Okay.
Yeah.
Hello. Thank you.
Yeah, thanks. Are there any more questions? So if you are planning to go into production with this one, what we recommend is using technology-like customized to use along with Ballerina generated artifacts. What you can do is you can use the generated artifacts and add modifications to that one using the customized technology, where you can inject like access tokens and other company specific things into the application.
So hi, I have a question.
Yeah.
It's like how we supposed to create a multi-service project that has like multiple services are running on in a Ballerina programming. So let's say like there can be a multiple services can be shared the same like data structures and libraries. So for example, let's say a order management system kind of a implementation. So there can be a shared data structures and util function that we can use. So what would be the the recommended way of creating a multi-service Ballerina project? Can we build it like with a simple Ballerina project, or do we need to create a multiple Ballerina project for each of the services?
At the moment, what we are doing is for a multiple project, we create a single deployment with multiple services. So since we are generating a single jar file for a project, we are packing that one as a Docker image and deploy it as a single deployment. So if it is a single project, you can only scale it as a single deployment.
So is it like if we are having like repetitive codes, then we recommended way is like we are using Ballerina Central to push those and reuse it, or is that the recommended way?
Yeah. So if I can add something to what Anuruddha said, Danushka, so right now, as far as I understand, a single Ballerina package, I mean, if you put services, then if you put services in a single package or a project in this case, all the services will be in one pod, right? So all the one bundle. But if in your case, if you want to put multiple services that you can deploy independently into different pod and scale differently, then the ideal approach is to put them into multiple packages. And then the question you ask is, if there are shared code, then we can put that code in another package. Right now, the only way to do is you have to share it to Central, but I think we are working on a solution. We have the other concept called multi-package projects. So in a single Ballerina project, you can have multiple packages and you can share between these packages. In that case, you can have your shared code, utilities, and everything in another package, and your services in other packages. Does that answer the question?
Yeah, so this multiple package thing is like still not supported in the Swan Lake 8, right?
Yeah, it's not supported in Swan Lake Alpha, but it's sort of addition, and we are planning to add it maybe in Swan Lake updates releases.
Okay.
And there's another feature that we are thinking of, rather than pushing everything to Central. Let's say you don't want to push your shared code into Central. We are thinking of another approach where you can push that package to your local home repository that's in your local machine. In that way, in your service, you can just import and use it. So it won't go to Central.
Okay, so another question is like, can we create private repositories in the Ballerina Central? Right? No, right?
Not right now, but that is that there is also work going on with that. So right now, no, but that will also be part of the Ballerina Central soon. So you can have your private repositories.
Okay.
There's actually a question on YouTube from Sebastian, how to connect to a React app that's also containerized so that Ballerina generated cluster now can talk and add the React app into cluster that's already created.
So yeah, so the recommended way is use the environment variables. So with the Ballerina, we can use this configurable keyword, configurable where configure keyword where we can specify a value URL to be taken from an environment variable. Let me show you a sample. So here you can write a configurable variable where you can provide the URL of an existing service you want to talk, and we can pass this value as a config map in Kubernetes. So if you look at this kubernetes.toml, for this sample, we have this config file mount, which will be generated, which we can provide to inject the URL of the backend service. Does that answer your question?
Excuse me, I have one other question.
Yeah.
Like if I have a set of services that are need to talk to each other, is there a way to configure an internal network in this TOML files? Or is supported?
Yeah, what we recommend is use environment variables as configuration for those URLs and provide it as a config map in Kubernetes. We do not generate that config map.
All right. Thank you.
So all the values for each service should be taken from the config map. Right?
Thank you.
Otherwise, it's more like orchestration thing. That part we haven't still done.
So I have another question. Like in the previous Ballerina versions, we have like Helm chart support and Istio support. So
Yeah.
in this new version also, we are getting that. I mean, even
no,
though it's currently not there, do we have it in later releases or something?
The reason that we have dropped those things was it's not scalable. Like we cannot support everything in a single TOML file and in a single or a annotation or multiple annotations. So what we recommend is use the customize to inject the required path to this generated YAMLs. So even if you deploy on Istio, you have Kubernetes deployment and service, etc. So what we recommend is use these YAMLs and update that one using customers. But in future, we may look into OpenShift and other artifact generation as well with -- cloud option. At the moment, this is the recommended approach.
I guess there's a question as in comment in the Zoom chat. With multiple services, keep separation of concern in mind. Private home repos are much desired. I think, yes, that is in the plan. So from when you develop a package, we are thinking of a way to push that package to your local machines repository. So that will be added in the future.
Thank you. And the private repositories is about more than just something like intellectual property. When we look through Ballerina Central, there are often multiple instances of different packages because we each may push the same kind of functionality up to Ballerina Central with the same names.
Yes, that's true. I guess you meant to say the private repos in Ballerina Central or private, home repos in your local machine?
Both would be desirable. It would be great to have to be able to push to Ballerina Central and call it private, both for testing before releasing to open source, and also for areas where there is significant IP involved. But then being able to deploy that to a local machine repository for efficiency would be great.
Okay, understood.
And on the topic of separation of concerns, if you're looking at bundling multiple services together, I would just caution to be aware that sometimes services need to be shared across multiple projects. And if you separate those concerns and bundle at the Kubernetes level rather than at the Ballerina level, then you'll be in much better shape.
Yes.
For instance, I do my service composition with one service so that I can orchestrate different services together. My data services are in another service, but these are not bundled together in one Ballerina package, but rather in separate services that talk to each other via HTTP.
So you usually put one service in a package and design that way?
As much as possible. I mean, there are cases where you do want them to be tightly coupled, but the loose coupling with contracts together gives you a great deal more agility going forward and scalability in your code.
Exactly. And I think our recommendation is also Ballerina package is a single unit. So we call the application package. So that could be a main program, or that could be a single service. Again, that's also our recommendation.
Any more questions?
So in the build command that you have issued, you put that minus cloud equal K8s. Yeah. So that's the command you have issued, right? So is there any other deployment we are supporting other than Kubernetes? So
no, at the moment it's Kubernetes. We are planning to expand on Azure Functions and other AWS Lambda.
Yeah, but for the moment, the old way also still works, right, Anuruddha?
Yeah. All for the moment, annotations are still working.
Yeah.
For Azure function as a service.
Hi, Anuruddha. I have one question regarding this particular example. So in here we have used key stores and trust stores. So
Right.
are they going to map with Kubernetes? How they are going to map with Kubernetes artifacts?
So each will be generated as a secret. So if we compile this one, it will generate a secret file and it will be mounted to the Kubernetes pod. So this
Okay.
this path will be created inside the pod along with this key store and trust.
Okay, thank you. So those will be mounted as volumes.
Yeah. Yes. A secret will be created for this key store to key store and trust store, and those will be mounted as volume mounts to the each pod.
Okay.
Okay, looks like there are no questions. Shall we wrap up?
Yeah, sounds good. Let's wrap up.
Okay, thank you for joining. Please reach us on our channels. We welcome your feedback. Bye.
Bye.
Thank you. Bye.